A warm welcome. This is electric energy generation, utilization and conservation course focusing on the lecture 4.3 traction, motors and control along with the recent trends in electric traction. It should have a simple speed control. So the speed control should be simple, that it should not be a simple one. So the control for traction motors for starting and for smooth acceleration is very much essential to avoid any damage to the motors. So the control equipment may be either manual or automatic. Usually a master controller is used for the purpose. Let us see what and all the types of control are present. One is a DC series motor control or plain rheostat control. Second is the series parallel control. Here we have open circuit transition, shunt transition control and bridge transition control. The third one is a Metatime control, and finally we have multiple unit control. We have used only one rheostat. Instead of that, we can use many number of rheostats based upon our requirements. So when rheostats are being connected in series, then the total resistance will be increased. Then while you are considering the shunt transition, the simple difference between the series position and the shunt transition is that in shunt transition case, we will be parallelly connecting, or we can see the armature and the field winding are parallelly connected to the next series armature field connection. That's a parallel, it's a parallel connection. And in shunt transition method, they are connected both, the rheostats are connected in series, and here we can see the motor connection is in parallel. So such a type of series parallel control will enable the speed control into a positive manner. It will increase the impact of the speed control. Next, let us see the first parallel and parallel shunt position. In this case, we can see the entire case of a parallel connection between two motors, then the series connection of the rheostat. Next, let us see about the bridge transition control. Bridge circuit is nothing but it has four arms with various elements connected to it, and the condition of electricity supply can be measured only when the bridge is balanced. So let us see the case here. Here the nodes are A dash and B dash. We have connected an armature and a field winding. That's a motor here. Then we are having the rheostat, adequate rheostat on one side, which is a variable one. And then here we have the next motor and the rheostat connection. You can see it is a variable one. Here the arrow mark is present, so it's a variable one. So this is the starting point of the rheostat. If suppose we are varying this position automatically, the rheostatic value will also be varying up, and in such a way we can control the balance. For example, in whether if it is not this connection, the rheostat is brought here and this position is brought there, this will be the case. And automatically we can say how whether the transition is at a step position or not. Second is for the first parallel position, this is how the connection will be. That is, the rheostat is connected to the this point is connected here, this point is connected here, and this point is connected here. In such a case, we can see that there is no flow of any current in this circuit. Here the flow of current is entirely present in this link. So in this way we can have two different types of bridge transition control. And the next one is the Metatime control. In Metatime control, we can simply see that we have four poles in the stator, and while considering the rotor, we have four brushes A1, A2, B2 and then B1. We are supplying the DC supply across the brush A1 and A2, and we have connected the load across the brushes B1 and B2. Now let us see, when we are applying the DC supply, the current will be flowing through the brushes A1, A2. In such a case, we can see how the flux is passing through. Now if it is A1, A2, the connection is A1, A2, then we can see that the flux passage through this pole to this pole is highly concentrated, because it is more, the flux passage will be more in this direction, since the load is being connected to B1 and B2. In this Metatime control, the the path of the flux determines the traction motor speed control. If more, I mean, if DC supply is increased, more amount of current will be flowing and more amount of flux will be generated. Since flux is more, automatically the speed will be increased. So when we reduce the flux value, automatically the speed of the motor can also be brought down. And while considering multiple unit control for city sides and urban suburban services, motor coaches are normally employed. Each motor coach may have one or two trailer coaches. These motor coaches must be capable of control from a single point. This object is achieved in multiple control unit. If you are having more number of control units, then this will be easy for the operation of those motor coaches. A unit of train equipment consists of a group of 2 or 4 motors in every motor coach, and provided with the series parallel controller, reverser, starting resistance, and control gear. All these are the components of the traction. So the controllers and the reverser are controlled by a master controller in the cab of any motor coach. The electric cables joining the various units are called the coupling cables. In this way, when we provide a multiple control unit, then the efficiency of the controlling aspect will be improved. And recent trends while considering electric traction are the magnetic levitation, maglev, it's otherwise called maglev, or magnetic suspension. Then mechanical constraint, pseudo levitation can also be considered to be the better one in electric traction application. Diamagnetism and then direct diamagnetic levitation. All these are supposed to be the recent trends of electric traction. Thank you.